Hello students, in this video we are going to discuss 4.7, 4.8 and 4.9. Here, two long and parallel straight wires A and B carrying currents of 8.0 ampere and 5.0 ampere in the same direction are separated by a distance of 4 centimeter. Estimate the force on a 10 centimeter section of wire A. Here, assume that this is wire A and it is wire B. In both of them, currents are same direction. IA is equal to 8 ampere and I suffix B is equal to 5 ampere. Both are separated by a distance of 4 centimeter. Now we need to find out the force on 10 centimeter section of wire A. Okay, the given values: I passing through A is 8 ampere, I passing through B is 5 ampere, separation between them is 4 centimeter and length on which the force has to be acted 10 centimeter. Here both directions of the currents are same. That's why force acting on A, F suffix AB, I am writing force on B due to A is F suffix B A. Both forces are attractive in nature. Now, the force per unit length is equal to mu naught times of current passing through A and current passing through B divided by 2 pi into D. That is equal to 4 pi into 10 power minus 7 and current passing through A is 8 ampere through B 5 divided by 2 pi into D value 4 into 10 power minus 2 meter. In terms of SI we will write, so 4 into 10 power minus 2. So that is equal to 2 into 10 power minus 4 Newton per meter. Now we need to estimate the force on 10 centimeter section of wire A. Therefore, force on 10 centimeter of section of wire A, F is equal to, we can write force per unit length into length. Force per unit length we have 2 into 10 power minus 4. Length on 10 centimeter. So 10 centimeter we can write 10 into 10 power minus 2 meter. So 10 into 10 power minus 2. That is equal to 2 into 10 power minus 5 Newton. And the force, it is the magnitude of the force. And while coming to direction, it is the attractive force acts normal to A towards B. So this is the direction. Coming to 4.8. A closely wound solenoid 80 cm long has 5 layers of windings of 400 turns each. The diameter of the solenoid is 1.8 cm. If the current carried is 8 ampere, estimate the magnitude of B inside the solenoid near its center. Here, the given values. The length of the solenoid 80 centimeter. If you are taking, this is the solenoid. Its length is 80 centimeter. And the number of layers are 5 and windings of 40 turns each. So therefore, number of turns per unit length, small n is equal to n divided by L, number of turns per unit length. That is equal to, here number of turns per layer into number of layers divided by length of the solenoid. That is equal to 400 and number of layers are 5 divided by 80 into 10 power minus 2. So this value will give us 2500 meter inverse. Now magnetic field at the center of the solenoid, B is equal to mu naught Ni. Mu naught is 4 pi into 10 power minus 7, n value 2500 into current passing through the solenoid is 8. So therefore, this value will be 8 pi into 10 power minus 3, that is also is equal to 2.5 into 10 power minus 2 Tesla. So this is the magnetic field at the center of the solenoid. Coming to 4.9. A square coil of side 10 cm consists of 20 turns and carries a current of 12 ampere. The coil is suspended vertically and normal to the plane of the coil makes an angle 30 degrees with the direction of uniform horizontal magnetic field of magnitude 0.8 Tesla. What is the magnitude of the torque experienced by the coil? That means the current carrying coil is suspended in uniform magnetic field, and the given values are area of the coil. It is in the form of square, so 10 centimeter into 10 centimeter, that is 100 centimeter square. That is also can be written as 1 into 10 power minus 2 meter square. And angle between magnetic field and normal of the square coil, that is area vector, is 30 degrees, and strength of the magnetic field 0.8 Tesla. Then the magnitude of the torque, it will experience a torque. So the torque tau is equal to NIAB sin theta. So that is equal to number of turns 20, I value we have 12 ampere, A value 1 into 10 power minus 2, and B 0.8 into sine of 30 degrees. So that is equal to 0.96 Newton meter. That is torque acting on the current carrying coil placed in uniform magnetic field. Thank you.